All right, now we're going to do a similar problem to the last one. We're still going to have dy as my starting point, but then we're going to do dx before we do dz. So let's not reinvent the wheel. We already found that 0 is between, y is between 1/2 square root of 36 minus 4x squared minus z. And we determined that when I smush down the y-axis, what I end up with is this picture. And I'm going to write something and then I'm going to have to erase some things, but I'll write it for now. It was easy enough to figure out that this shape on the bottom, so this was z equals 5x squared. And this shape above, we had to do a little bit more work, but we were able to determine that that shape equaled, I'll write this is z equals 36 minus 4x squared. And recall, we're looking at this purple region. My art skills have kind of gone downhill, but that's okay. We even found out that this point is 2. That's not going to be the most useful piece of information for us, but it's worth noting. Okay, so we have that. Did I finish that problem? Maybe not. Oh, that's why. Okay, I recalled. This is going to get weird. It's going to get a little bit weird because now I'm not interested in what's my top and bottom function. I'm interested in what's my right and my left function from this perspective. If I were in 3 dimensions, this is really talking about, because remember this is x, z. This is kind of like what's my forward function and what's my backward function, because we've kind of rotated things a little bit. So if we look at this, you'll notice that my function, the function that's on the right, changes. There's a part here, and we'll need to find where that intersection is, where for part of it, the blue function is to the right, and for part of it, the red function is to the right. Again, I drew this kind of bad. I'm sorry. So what we're going to need to do is we're going to need to split the rest of this problem into one part that deals with the blue function and one part that deals with the red function. So we're actually going to start with the red because I think that's going to be a little easier to work with. And then we're going to work with the blue. But one thing that we need to figure out is what is this intersection point? If you recall from the last video, we said that the x-coordinate here is 2. That doesn't help us because we need the z-coordinate. But the good news is, if I know the x-coordinate, then it's pretty easy to find what the z-coordinate is just using like this. So this intersection point is actually the point 2, 20. So my z-coordinate is 20. And I use this formula here. 5 times 2 squared is 20. So what we're saying is that from 0 to 20, when z is between 0 and 20, remember we're actually going to do z last, but I kind of need to talk about it now. When when z is between 0 and 20, then the function on the left is still going to be 0. That's my lowest x-coordinate. But my rightmost x-coordinate is going to be this thing solved for x. So we're going to need to actually take this and rewrite it in terms of x. Or solved for x, I mean. So we had z equals 5x squared. You can divide both sides by 5. Square root. Obviously, we're only using the right-hand side, so we're only looking at positive values, and we'll get that x is less than or equal to the square root of z over 5. And that would be how I finish out this set of inequalities for the red function. The blue function, where's that going to? Well, this we need to figure out what this point is, and hopefully that's not too bad. Just plug in 0 for x, and you'll see that this point is going to be 0, 36. So that tells us that when z is between 20 and 36, my function is going to be, my x values are going to be between, okay, now I need to take this equation, z equals 36 minus 4x squared, and solve that for x. Oh, I should have written this up here. This guy is x equals square root of z over 5. And this down here is going to, let's go ahead, subtract z from both sides, add 4x squared to both sides. Square root and divide by 2, we should end up with that x equals plus or minus 1/2 square root of 36 minus z. That's a minus z, I promise you. And that's what we get over here. Okay, that was fun. So now we need to actually write our answer. And this is why I was questioning whether I did the problem, because I didn't actually write out the answer when I did this earlier. But that's okay, we'll do it now. Because what we have is we actually have two different integrals that we're going to be adding together. One for this bottom half and one for the top half. So for the bottom half, what we're going to do is I'm going to have the integral from 0 to 20. That's my z's. Then I'm going to have the integral from 0 to square root of z over 5. And then I'm going to have the integral from 0 to 1/2 square root of 36 minus 4x squared minus z. 2 dy dx dz. That takes care of the part where the red function is my right, or basically my frontmost function in this region. And then we're going to add on the integral from 20 to 36. Integral from 0 to 1/2 square root of 36 minus z. Integral from 0 to 1/2 square root of 36 minus 4x squared minus z. I think that was 4x squared. Yep. And have 2 dy dx dz again. All right, and now we have that integral written in the order y, x, z. The last thing we're going to do is we're going to do the integral going y, or x, z, y, and this one is going to be a treat. So we're going to have fun with it. Prepare yourself emotionally.